Now I want to find a sample size for a desired margin of error for a t-interval. So let's say that I would like to decrease my margin of error here from 0.8 to 0.2. Okay, so let's say I'd like to have my margin of error be 0.2 instead of 0.8. And I want to figure out what sample size I need. Okay, so let's think about this. Margin of error is equal to the t critical value with a certain degree of freedom times the standard error of the sample divided by the square root of the sample size. And I thought if the margin of error I want is 0.2 instead of 0.8, and let's say this was a 95% confidence interval. So this is 95% confidence. Okay. So then I would not need to find the t critical value for that desired level of confidence, and standard deviation and sample size. And so what I'm trying to find, sorry for the yawn there, but I run into a lot of problems here because I don't know what the t critical value is unless I know what the degree of freedom is, and I don't know what the degree of freedom is unless I know what the sample size is, and that's what I'm trying to find. So, and how in the world do I know the sample standard deviation if I haven't even taken a sample yet? So we run into several problems here. So let's start with sample standard deviation. We have to either make an educated guess or use a previous sample in order to guess the sample standard deviation. So I'm just going to use the sample standard deviation for my previous sample of M&Ms. I don't know if it's right or not, it's not that great of it, but it's the best I can do because I'm just trying to kind of reduce my margin of error, so I'm going to do the best I can with what I have. So this is 0.9589. Now, as far as the t critical value, I'm really in a quandary here because I cannot find a t critical value without knowing the sample size because that's what my degree of freedom is based on. So I have no choice but to substitute a z critical value. So I'm going to use the z critical value for 95% confidence, which is 1.96. Okay, so instead of t, I'm going to use z. Okay, so I've taken care of the two problems in the best way I can. So now solve this for n, for n, and so you'd have 0.2 divided by, actually I'm just going to, that's fine, I can do this. 0.2, I just didn't want to take a lot of time to do this, divided by 1.96 is equal to 0.9589 over the square root of n. So the square root of n is equal to 0.9589 times 1.96 all over 0.2, and then I just square both sides. So I'm just going to square all of that. And that will give me the desired sample size. So let me go ahead and do that computation here. I'm going to pause a minute. You go ahead and do the computation. Okay, so here I show one way of calculating it. Here I show using the solver, which actually I recommend just for quick ease of solving and to avoid making careless errors. You can use the solver. So I get 88.3077. So I'll just copy and paste these into the notes showing both ways of doing this calculation. Because really we're not testing you on computation as much as we are on understanding what the numbers mean in statistics. So not really terribly picky about this. How you do the solving. It'd be nice to know that you can do this, of course. So I end up with n equals 88.3077, but a sample size has to be a whole number, and specifically it needs to be rounded up to the next number. So I'm going to make n equal to 89. So I would say 89 is the smallest sample needed to guarantee a margin of error of plus or minus 0.2. Okay, so if I wanted to reduce my sample size, I would have had to use 89 bags of M&Ms instead of just 8 bags of M&Ms. Now, we did quite a bit of estimating. We had to use the Z critical value instead of the T critical value. I had to grab a standard deviation from a small sample that I had done previously. So this isn't perfect, but it's still a pretty good estimate of the number of samples I would need to reduce the margin of error to the desired value.